Hello class, this is Mr. Sutton, and today we're going to be talking about adding and subtracting rational expressions as well as solving rational equations. So your notes for this, the only thing you need to remember is that you need to get a common denominator in order to add and subtract fractions, which is something that I'm sure you already knew, but we have to apply it now to these algebraic expressions. So for this example, here we can see we already have a common denominator. So that means we can go ahead and subtract these. It says combine the following fractions and express in fully reduced form. So we can go ahead and subtract these. One thing to be careful about is the negative here. We're subtracting negative x, and we're also subtracting positive 2. So what I usually do here is I will go ahead and combine these into one fraction, and I'll go ahead and distribute the negative here and then rewrite it like that over here. And then the denominator is just 3. Remember, if you have like 1/2 plus 3/2, this becomes 4/2. We don't actually add or subtract the denominator together. The denominator stays the same. So same thing here. This over 3 plus this over 3 becomes this over 3. So now we can go ahead and combine like terms in the numerator. We have negative 4x plus 4x becomes negative 3x, and then 3 minus 2 becomes plus 1 over 3. Now we could potentially reduce further here, but there's nothing more to simplify. There might be something we could factor out that we could cancel with the denominator, but not in this case. So this would be our final answer. Now here's one where we do not have a common denominator. So thinking back to a normal fraction without any algebra, maybe something like this. We want to find a common denominator, and in this case our common denominator would have to be 14. So we would multiply this fraction by 7 over 7 to get 14, and this fraction by 2 over 2. So we get 7 over 14 plus 6 over 14. And then we can add them together. It becomes 13 over 14. We want to repeat that same process over here. Our common denominator is going to have to be this 3x, right? Because we already have an x over here, we're just missing the 3. So we don't need to multiply this fraction over here by anything, but we do need to multiply the left fraction by 3 over 3. So 3 times 9 is 27. And then this is 4 over 3x. So 27 plus 4 is 31. And then we just have the 3x on the bottom. And again, this does not simplify. If this was 30 over 3x, then we could reduce it to 10 over x, but that's not the case here. 31 over 3x does not simplify any further. For this one, you'll notice this negative 7 is not written as a fraction, so the first thing you probably want to do is rewrite that as a fraction. So I'm going to turn it into minus 7 over 1. And then now we want to come up with our common denominator. So the common denominator is going to have to be x minus 2. We can multiply this right fraction by x minus 2, and then we'll have 1 times x minus 2 is just x minus 2. So this left fraction we don't actually need to multiply by anything because it's already x minus 2. So you go ahead and do that. 2 over x minus 2, and then minus this numerator, 7 times x minus 2, becomes 7x minus 14. And then the denominator, 1 times x minus 2 is just x minus 2 again. And then the other thing you want to do is you want to make sure you distribute this negative. Now, you could have distributed it when you multiplied the 7 and actually just multiplied by a negative 7. I didn't do that, so I need to make sure that I do that now. So plus negative 7x plus 14. So then when I combine these, I have 2 minus 7x plus 14 over x minus 2. And I can combine the 2 and the 14, so I'll have negative 7x plus 16 over x minus 2. Now, does anything simplify here? We actually can't factor anything out of the numerator except for the negative 1 if we wanted to, but I don't see any reason to. Again, some people will maybe make this mistake of trying to cancel these x's, but remember these x's here are not attached by multiplication. This top x is attached by addition and this is attached by subtraction, so we can't cancel these because they're not being multiplied. And then same thing, someone might try to cancel the 16 and the negative 2. We can't do that because, again, they're not attached by multiplication. Those are part of these larger factors, so we can't cancel them separately. What we would need to cancel is if I had an entire x minus 2 factor up here, then I could cancel that, but that is not the case. So there's nothing that we can cancel here. So this would be our final answer. So now let's look at this one. Here we have two fractions, two different denominators, but these denominators are very similar. And the difference here is that they are opposite signs on the right side. So actually what you could do for one like this, you could take this 7 minus x and factor out negative 1. So then it becomes negative 7 plus x like that. Which this negative 7 plus x you could rewrite like this, x minus 7. So now you have x minus 7 over here and x minus 7 over here. So factoring out that negative 1 actually gets us a little bit closer. Now there's two ways you could go from here. You could either multiply this fraction by negative 1 over negative 1 to cancel out the negatives, and then you'll have x minus 7 in both denominators, or you can multiply the left fraction by negative 1 over negative 1, and then you'll have this negative 1 times x minus 7 in both fractions. I would rather multiply this side by negative 1 over negative 1 because I think the x minus 7 in the denominator is a little cleaner, easier to work with than negative 1 times x minus 7. So we then would have 3x plus x minus 7, and then plus 1 times, or 5 times negative 1 is negative 5. And then over here we have negative 1 times x minus 7. So negative 1 times negative 1 becomes positive 1. So then we're just left with x minus 7. So now we have a common denominator. We can go ahead and combine these in one fraction. 3x plus negative 5 becomes 3x minus 5. And then the denominator is still x minus 7. And this is the fully simplified version. If you did it the other way, if you multiplied the left fraction by -1 over -1, you're probably going to end up, you will end up with something where you're going to need to cancel out those -1s at the end to end up with this fully simplified version. So it's probably best to do it this way for this one. But you can still end up with the right answer if you do it the other way as well. Now let's look at this example. Here we are not close at all to having a common denominator. We have totally different factors in each denominator here. So for this one, to get a common denominator, what we'll have to do is we'll have to multiply the left fraction by this x plus 5 over x plus 5, and the right fraction by x minus 2 over x minus 2. So our common denominator is going to have to be x plus 5 multiplied by x minus 2. All right? And then for this type of problem where you're doing a lot of work to come up with these common denominators, for the numerators, you need to fully distribute and multiply everything. So I'm going to multiply this 2x times x plus 5. So 2x squared plus 10x. For the denominators, I recommend keeping it separate for now. Do not multiply the denominators out, because the thing is, the numerators, you need to multiply it out because you're going to have to combine like terms. But then after you do that, things might cancel. So you want to keep the denominators separate for now so that you don't have to refactor them later. So then the right side will have 5x squared minus 10x plus 2x minus 4. So again, keep the denominators separate for now. Now we can go ahead and combine these into one fraction. So now we can go ahead and combine like terms. So that would be 7x squared and then the 10x minus 10x cancels, so we're left with just the 2x and then minus 4. So then we have x plus 5 times x minus 2. So now this is where we can potentially cancel something here. We have a trinomial. Let's see if we can factor this and then potentially cancel out one of these factors with the denominator. So that's why we didn't multiply this out. We want to leave it factored here because now we're going to factor this numerator and see if we can cancel anything. So this does not actually factor. There are no two numbers that multiply to give us -28 and add to give us 2. So we're not going to be able to simplify this any further. That's okay. So we'll have to leave our final answer like this, and we can go ahead and multiply the denominator out now. So that would be plus 3x and then minus 10. All right. So that would be our final answer there. So now here we have another one where two totally different denominators. We're going to have to come up with a common denominator here. The one trick is that for a lot of these, they will already have one common factor to this. Potentially, if I factor this, it will be x minus 5 and something else. So that means you're already part of the way to having a common denominator. So you want to factor this. So yeah, that would be x minus 5 and x plus 3. So this fraction here already has an x minus 5, so does this one. So all we need to do is include an x plus 3 to this one. So we multiply the numerator and the denominator by x plus 3 to get the common denominator of x minus 5 times x plus 3, which is equivalent to x squared minus 2x minus 15. So this left fraction we don't need to multiply by anything. Go ahead and leave it like this. And again, we want to leave the denominator factored in case anything simplifies later. So then we have 1 times x plus 3. And then our common denominator. So now I want to distribute the negative as well. And now I can go ahead and combine into one fraction. And then we can combine like terms. So we have x minus x. The x actually disappears in the numerator. And then we just have 2. 5 minus 3 is 2. And so that tells me that we're not going to have any factors that cancel here. So we can go ahead and multiply the denominator as well. And one trick here, if you're like, oh, I really don't want to multiply these factors together, we actually already know what these factors are multiplied together. It is some work that we already did. We already took this quadratic and we factored it. So if you're going the other way, you just go back to this quadratic, x squared minus 2x minus 15. So this is our final answer here. So now we have the other type of problem. Here we're actually solving for values of x. So our fractions are in equations. We have an equal sign, so now we can actually solve for x. But very similar idea. We're going to have to get a common denominator for these. So I'm going to rewrite this as a fraction, negative 3 over 1 minus 6 over x minus 6 equals x over x minus 6. So our common denominator is going to have to be this x minus 6 factor. So I'm going to I'm going to multiply this left fraction by that. So then they'll all have an x minus 6 in the denominator. So this negative 3 times x minus 6 is negative 3x. And then negative 3 times negative 6 is plus 18. So now from here, since we have common denominator, we can go ahead and combine the left side into one fraction. Minus 6. And then the other thing we can do, we can actually forget about the denominator since it's a common denominator. If you think about how we add fractions together, like if I have 2/3 plus 5/3 equals 7/3, the denominator, if it's common, doesn't really play a part in the actual arithmetic of what's going on here. You could look at this 2 plus 5 equals 7 on its own without the denominator. The denominator is not important. Once we have a common denominator, it adds like normal integers, right? So we don't really need this x minus 6 here. We can kind of ignore that and just look at this like a regular integer equation that we can now solve for x. So I'm going to go ahead and do that. So I got x equals 3. I added 3x on both sides, and then 18 minus 6 is 12. X plus 3x is 4x. Divide by 4 on both sides, and I got x equals 3 for that one. So now let's look at this next one here. I'm going to have to write this 1 as 1 over 1 to make it a fraction. And then you have to make a choice here on where you want this negative to be. I'm going to make it -1 in the numerator just to kind of leave my denominators clean for now. And then another thing you want to do, if you can factor your denominators, you want to factor the denominators like we talked about earlier, because that tells you what factors you need to have in your denominator. So if we want to find a common denominator, our factors in our denominator right now are x minus 3, 1, and x times x minus 3, right? So the factors we need to have are 1, which doesn't really do anything, right? You multiply by 1, doesn't change anything, x, and x minus 3. So our least common denominator has to be this x times x minus 3. All right? So that's one way you can think about coming up with your least common denominator. So that means this left fraction is missing the x, so we're going to multiply by x over x. This fraction is missing both things, so we're going to multiply by x minus x, or x times x minus 3. And then this fraction is not missing anything here. It has both the x and the x minus 3. So we can go ahead and start multiplying. X times x is x squared. And again, the numerator stuff, go ahead and multiply out. The denominator, you can leave as factored. So this becomes x squared minus 3x. And then equals -1. And like I said before, once you have your common denominator, which we do, all the denominators are x times x minus 3, we can go ahead and ignore that and solve the equation just looking at the numerators. So x squared plus x squared becomes 2x squared minus 3x equals -1. So this is a quadratic. I got to add the 1 to the other side. And so now to solve it, I need to factor, set each factor equal to 0, solve for x. So I'm going to go ahead and do that now. So it factors to 2x minus 1 times x minus 1. Set each of the factors equal to 0. Add 1, divide by 2, and you get x equals 1/2. Add 1, you get x equals 1. So these are your two solutions here. X equals 1/2 and x equals 1. And then, yeah, here's the last one. I'm going to go through this one here. Same idea. We're going to come up with common denominator. Here, there's nothing to factor initially. So our factors in our denominator are x plus 2 and x minus 2. So our least common denominator has to be x plus 2 times x minus 2. Right. These two already have the x minus 2, and this one already has the x plus 1, or x plus 2. So we're going to multiply this one by x minus 2 over x minus 2. Multiply this by x plus 2 over x plus 2. And this one by x plus 2 over x plus 2. So 7 times x minus 2 is 7x minus 14. Two times x plus 2 is 2x plus 4. And then x times x plus 2 is x squared plus 2x. Now that we have our common denominator, each denominator is x plus 2 times x minus 2. We can go ahead and get rid of that and just look at the numerators as an equation. So we have 7x minus 14 plus 2x plus 4 equals x squared plus 2x. So here we have an equation that I'm going to go ahead and solve. This is going to be a quadratic because we have an x squared here, so you have to get everything to one side of the equation and then factor, set each factor equal to 0, and then solve each for x individually. So I'm going to go ahead and do that now. So when I got everything to one side, I got x squared minus 7x plus 10. And when I factor it, I got x minus 5 times x minus 2. Set each factor equal to 0. Add 5 on both sides, you get x equals 5. Add 2 on both sides, you get x equals 2. Now there's one other element to this type of problem, and that is there's a potential for a divide by 0 here. And it happens in this one. Since I have this x equals 2, if I take that 2, if x really equals 2, if I take that and plug it in here into my original equation, notice what will happen is you will get a 2 minus 2 here, which becomes a 0 in the denominator, which means we're taking 2 divided by 0. And I think we all know that you cannot divide by 0. That is a big no-no. So that means this cannot be one of our solutions because this is a divide by 0 case. So that means x equals 5 is our only answer. So that's one thing to add in your notes. That's something that didn't come up on the last problem, but on this one we did have a case where we got x equals some value that it actually cannot equal because we would be dividing by 0. So x equals 5 is our only answer for this one. So make sure you have that in your notes as well. If you have any questions about any of this, make sure you ask for help during class, and have a good day.